Okay, so in this video, I'm going to be working on showing you how to graph polar equations on a polar coordinate system. Okay, and what you're going to want to do, I think, is just do a quick read of section 7.4. It helps to see the gist of what these look like. And I'll tell you that there's ways to graph these that depend on more analytic things like looking for symmetry and that sort of thing. But I just wanted to expose you a little bit to polar graphs. So I'm going to do 3 examples here, and then I'm going to ask you to graph 2 for me to turn in. Okay, so if you're just going to graph by plotting points, what I sometimes do is just take the unit circle and go and take all the 30-degree angles. Okay, so take all the 30, the 60, the 90, and so on. So I went ahead and made some graph paper you could use for that. And then if you need some more in between, you could add in the pi over 4, the ones that are related to pi over 4. But this usually is enough to get the idea of what it's going to look like. So I wanted to just get you started with how you might do that, and then I'll show you the finished table, and then we'll go ahead and be plotting the finished table. Okay. So what I like to do, if I'm trying to get the ordered pair, it's here at the end. I'm looking for ordered pairs in polar form. So there'll be r theta. So here are all the different thetas I'm going to be using, and then I'm going to calculate r using whatever the equation is. Okay. So sometimes it helps to do a progression of things until you get to the r value. So if you know theta, you would then want to do sine theta. Then you could do 2 times sine theta. And then you could do 1 plus that. Now you could do that all at once, but sometimes I find it helpful to just separate it out a little bit. And then I know when I get to here that this is my r, and that's what I'm going to use to write my ordered pair. Okay. So for instance, you know sine theta. I'm just going to do, maybe up through pi, and then I'll show you the finished product. So the sine of 0 would be 0. Okay. The sine of pi over 6, so let me think about that. So sine of pi over 6 would be 1/2. Sine of pi over 3 would be square root of 3 over 2. Sine of pi over 2 is 1. When I get to 2 pi over 3, the sine is going to be, again, square root of 3 over 2. 5 pi over 6, that's going to be over there at 1/2. Pi, you're back at 0. Let me just do a couple more. 7 pi over 6, the sine's going to be negative 1/2. 4 pi over 3, the sine's going to be negative square root of 3 over 2. Just have your unit circle sitting there, because what we're picking is going to wind up being things on your unit circle. The sine of 3 pi over 2 is negative 1, and so on. You would just finish that up. Then you would go in and do 2 times that. So if I did 2 times that, I'd still be at 0. Here I'd be at 1, square root of 3, 2, square root of 3, 1, 0, negative 1, negative square root of 3. And here, what am I multiplying by 2? So that'd be negative 2. And then keep going like that. And then just add 1 to everything. So that would be 1, 2, 1 plus the square root of 3. This would be 3, another 1 plus square root of 3. This would be 2, 1, 0. This would be 1 minus the square root of 3, because I'm adding 1, but the square root of 3 is negative. Here I'd get negative 1, and so on. And so then I'm able to see my ordered pairs. So it'd be 1, 0. And then it'd be 2 pi over 6. And then 1 plus the square root of 3 is about 2.73, I think. Let me see what square root of 3 is again. I should know that, but I just don't want to say the wrong thing. 3, square root of 3. Yeah, that's 1.73. So that'd be 2.73. So it'd be 2.7 about with pi over 3. You see? And so then I got all these ordered pairs, and now I just need to go and graph them. Okay, so let me go a little further down. So let's say we're down here. Okay, see how this would have 0 with 7 pi over 6, and then you get some negatives. This would be negative 0.71, and that's at 4 pi over 3. So I have to remember how those work. Okay, and this would be negative 1, and that's at 3 pi over 2. Okay, and so on. So we could continue that to get the table filled out. Okay, so here's what it would look like. Let me see if I can find the completed table for the limison. So here's the completed table. Okay, Uh-oh. Okay. Let me go back. Why did it do that? Let me undo. Okay. Here we go. So here's the completed table for that. Okay. And so then after we get the completed table, we'll want to go in and sketch the graph of it. Okay. So, and I'm doing the limison, right? Yeah. Okay. So what I'm going to do is go pull up the graph paper, and I posted some of this for you. And you just start plotting those points. Okay. So I'm using those ordered pairs that we had on that table. I can't easily pull up both things. I'm going to see if I can snip it so you can see it and I can write on it. So let me do a full screen snip. Okay. All right. And then let me see if I can snip that table and do a snip of it as well. Okay. And so what I want to try to do is leave them both on the screen so you can kind of see the process. Move that sharing. Okay, so what I'm going to do is just kind of show you how to begin plotting it. Actually, we'll go ahead and just finish plotting it. It doesn't take long to plot the whole thing. So what you do is you just start plotting those points. So at 0, you're out at 1. And really, it'd be nice if this were fewer rings, so that, because these are pretty small numbers. Okay, at pi over 6, you're out on ring 2. At pi over 3, you're at 2.73, so about 3/4 of the way there. Okay, and then at pi over 2, you're all the way up at 3. Okay, and then it kind of starts going around in a similar way. So 2 pi over 3 is also at around 2.7. And then 5 pi over 6, that one's at 2. Okay. And then when you get to pi, you're back at 1. And then here's where something interesting happens, and this gets a little harder to do when you're new to polar coordinates. Okay, 7 pi over 6, which is right here, you're at 0. And then after that, do you see how you have a negative on your R values? So when you're here at 4 pi over 3, you're supposed to be at negative 0.73. So remember how you go backwards on that 4 pi over 3 line? So rather than going on this line this way, you go backwards, and 0.73 would be almost to negative 1. So it should be like right there. And then see how when you're at 3 pi over 2, you are at negative 1. So that's going to be all the way up there. Okay. And then when you go around to 5 pi over 3, see how you're at that negative 0.73 again? Okay. And then at 11 pi over 6, you're back at 0. Okay. This is one of those, they have like an inner loop on it. It's a very cool little graph. So let me see if I can hit all those points. So you come around once, and then you take that little inner loop again. And of course, we could go in and we could look at, we could see what happens like at pi over 4, at 3 pi over 4, okay, at 5 pi over 4, and at 7 pi over 4 if we needed some more information or if you wanted to like flesh it out a little bit more, okay? All right, so let me see if I can blow that up just a little bit more so you can see it. So it kind of goes around and then it has a little inner loop in it. Isn't that kind of neat? All right, so this one right here, this was the R equals 1 plus 2 sine theta. Okay, and that's a limison. Okay. All right, so they look kind of interesting, and you can read about them a little bit in that section 0.4, just to kind of get a sense of them. All right, let's look at another example. So let me do a Lemnis Gate next. That was the limison. Let's see, not the rose curve. Yeah, let's do the rose curve. I'll do a rose curve next. Okay. I think I'm starting to have issues with too much stuff open. Okay, so let me see if I can shut some of that out. Let me go ahead and close these off. So I want my rose curve open. Okay, there we go. All right, so a rose curve. So here's something that fits the pattern for a rose curve. Okay, so I'm going to go ahead and do like I did before and look at a progression of values just to help me keep it straight. So I'll do 2 theta, then I'll do cosine of that, and then I'll do 3 times that, and then I'll put it together into the ordered pair format. And then this is the column that I'll go and plot. All right, so if I do 2 times theta, then I'm just going to run through and do that real quick. Thinking about doing 2 times the theta. So I'm just doubling all of these. Okay, so I can do that all the way down. Okay, I'll stop because I'm going to show you the finished version in a minute. Then you would go in and do cosine 2 theta. So you'd think about, okay, I need cosine of 0, and cosine of 0 is 1. Cosine of pi over 3, that's really 60 degrees. The cosine is just a half. 2 pi over 3 is in the second quadrant, so it's -1/2. Cosine of pi is -1. Then at 4 pi over 3, you're back at -1/2. 5 pi over 3 is fourth quadrant, so you're positive again. Cosine of 2 pi is +1. Okay, then 7 pi over 3 is really wrapped around a full rotation. It's really back at pi over 3, so you're at 1/2. So you can kind of subtract 6 pi over 3, but you're going to start repeating, it looks like. Anyway, so you finish that. Then you come in and do 3 times it. So that's 3. That's 3 halves. It's -3 halves. It's -3. -3 halves, +3 halves, 3. 3 halves, -3 halves, and I would just keep going. And then I would come over here and think about my ordered pairs. And when I'm thinking about 3 halves, the decimal is what you really think about because you're going to use this to graph. Okay. Okay, so you just put them together as ordered pairs. Then you go and you plot them. Okay, so let me pull up another piece of graph paper. We'll do the rose curve. All right. All right, so when you do the rose curve, this one's kind of interesting and fun. Let's see what we wind up getting as we plot those. Okay, so I was doing the rose curve. Oops, let me snip it so I can write on it. Okay, and then let me go try to pull up the graph we just did for the table. Let me pull up, this is the completed table for it. So let me snip that. Get that out of the way. Okay, and then let me try to keep these 2 things on the screen at the same time, and we'll start plotting them. Okay, so I'm going to plot the point 30. Then at pi over 6, I'm at 1.5. Then at pi over 3, now see how it has a -3 halves? So when I'm at pi over 3, I have to go opposite 1.5 keep going backwards on that terminal side until you get to 1.5. That was at pi over 3, okay? Then at pi over 2, I have -3. So when I'm at pi over 2, I go this way to -3. See, this would be the terminal side for that. So I go backwards 3. Then 2 pi over 3, which is here, has a -1.5. So I'm going to be over here. Okay. Then 5 pi over 6, which is there, has a +1.5. So I'd be out here on the terminal side itself. Okay, then pi, I'm at 3. At 7 pi over 6, I'm at 1.5. Okay. So where was I? 3 pi over 2. Let me go to there. 3 pi over 2. I haven't done that yet. Okay, 4 pi over 3, I'm at Okay, I think I did 7 pi. Let me just start at pi, sorry. At pi, I was at 3, so I got that. Okay, then at 7 pi over 6, which is here, I was at a positive 1.5. Then at 4 pi over 3, I'm at a negative 1.5. So I have to back up on that and hit it over here. Oops. I don't want to erase everything. I just want to erase that one. Negative 1.5. So about right there. Okay, that was 4 pi over 3. Okay, at 3 pi over 2, here's 3 pi over 2, but I have to go negative. So I'd be up there. And then 5 pi over 3, this is 5 pi over 3, and it's a negative 3/2, so I have to back up 1.5. Okay. And then at 11 pi over 6, which is here, I'm at a positive 1.5, so that's there. And then when I get to 2 pi, I wrote that wrong. That should not have, that right there is incorrect. That should have said 2 pi right there. When I'm at 2 pi, I should be out at 3. So 2 pi would be there, and I've already got that. All right, now this looks hard to see. That's why I think it helps for you to see a little bit. This of what they kind of turn out to be. This will turn out to be a rose curve, and what we're graphing is r equal 3 cosine 2 theta. And so it winds up really having these petals that look like this. Okay. There we go. And so the 3 has to do with how long the petal is. And then when you have like a 2 theta on that, that can give you some information about what to expect as well. So if you'll look in that section 7.4, you can get some good information about that. So if you have 2 theta, you're going to have 4 petals. If you had 4 theta, you're going to have 8 petals. But if you have an odd theta, like a 3 theta or a 5 theta, you'll have exactly that number of petals. And then the number out in front actually is going to tell you how long your petal is going to be. So it gives you almost like the radius of it. All right, so those are pretty interesting, and you see the gist of how to graph it. You just complete your table and then carefully go in and plot it. So that's a rose curve. All right, I wanted to show you one more. So let me go ahead and get rid of these guys because it has a hard time bringing up too much stuff at once. And let me go get the last one I'm going to do, which is a Lemnis Gate. Okay. It sounds like a biological creature. All right, so let me snip that. We're going to do that in a minute. Well, let me not do that yet. Let me pull up a table that I can fill in. Let's see if this is the Lemnis Gate. Okay, here we go. So we're going to graph a Lemnis Gate. Okay, so what I'm going to do for that is I'm going to do the 2 theta. Then I'm going to do the cosine of 2 theta. Then I'm going to do 4 times the cosine of 2 theta. All right, and at that point, I have my r squared. This is my r squared. So then I'm going to do plus or minus the square root of that. Okay, and then that's going to give me my ordered pair over here at the end. Okay, so we'll do several of these again, but then really I'll just show you the completed one. So we just go in and double everything. Okay. So if we double everything, we'll start that process. Okay, and I'll just go a little bit further, like to here. Okay, then we'll do the cosine of it. So 1, 1/2, negative 1/2, negative 1. Here we're at 4 pi over 3. That's in the third quadrant, so that's also negative 1/2. 5 pi over 3 is back to positive. 2 pi is, cosine of 2 pi is 1. 7 pi over 3, if you take away a full rotation, if you take away 6 pi over 3, you're back at pi over 3, you'd be back at a half. Okay? So now I'm going to do 4 times that. So that would be 4, then 2, then negative 2. Then this would be negative 4, negative 2, 2. This would be positive 4, This would be 2. Then I need to do plus or minus the square root. So some interesting things happen here. So I get plus or minus the square root of 4, which is 2, plus or minus the square root of 2. But when I do the square root of -2, it's not a real number. So it can't be graphed in something involving real numbers. So it's not real. This one's not real. It would have an imaginary number. This one's not real. But then we're back at plus or minus the square root of 2, plus or minus 2, plus or minus the square root of 2. So when you go to plot your ordered pairs, you actually get 2 ordered pairs here. Okay, so we're going to do r theta. And so it'll be plus or minus 2 when you're at 0. Okay, plus or minus the square root of 2 when you're at pi over 6. And make sure you're taking these. That was a mistake I made on one spot on the last graph. And then these, you don't have an ordered pair to plot. Here you got plus or minus square root of 2 together with 5 pi over 6, and so on, okay? Plus or minus 2 with 2 pi, and so on, okay? All right, so the completed table for a Lemnis Gate. So here's where I've completed the table. Let me see if I can get that to not have that extra little, there we go. So here's your Lemnis Gate. All right, so I'm going to snip that one and bring up the graph paper to do the graph. Okay. And I want to snip it. Okay, so I'm going to try to get a pretty decent graph of this. All right, so here we're trying to plot this Lemnis Gate. Okay, so this turns out to kind of have an interesting thing happen. All right, so when we get to plotting, we have 2 ordered pairs with every, with a bunch of the angles. So when we're at 0, we have to be out on the second ring. Let me get the red to be over here. Okay, there we go. We have to be out on the second ring, +2, and then we can back up and be over here, -2. So that's these 2, okay? Then we're at pi over 6. We can be at +1.41, so a little less than halfway. Okay, and then also have a point where we go to pi over 6 and we go to -1.41, a little less than halfway to 2. Okay. All right, then all of a sudden there's nothing. Okay. And then we get down to 5 pi over 6. So we're going to go over here to 5 pi over 6. Okay, so here we are. And at 5 pi over 6, I have that 1.41 positive or negative. So I'll be out here at 1.41. And then in the negative 1.41. Okay. Then at pi, I have positive or -2. So see how I'm back to these same 2 points? Okay, because pi +2 would be here, pi with a -2 would be here. So this is +2 pi, this is -2 pi. Oh, we're starting to repeat. 7 pi over 6, I have 1.41, which is already on here, and then also the -1.41. Okay, and if I go all the way down to 11 pi over 6, I already have what I needed. Here's 1.41, here's -1.41. And at 2 pi, here's 2, and here's -2. So this is it. You get something that looks like an infinity symbol. That right there. That's your Lemnis Gate. I didn't draw that very well, though. Let me see if I can knock that one line out. So it comes around, even worse. Okay. So it's hitting those points. Okay. So it looks something like that. So that was a Lemnis Gate. And the one I just did was r squared equals 4 cosine 2 theta. And so if you want to, you can read a little more about those. They're in section 7.4. So they're kind of interesting. The length of what appears to be a petal comes from here. The square root of that gives you how long the petal's going to be. And then depending upon whether you have sine or cosine shows whether it's going to be symmetric. If If it's cosine, it's kind of like this. It's in that lays horizontally. Okay. All right. So I'm going to stop this, and I'm going to propose that you try to graph a couple, um, one of each of these, and you can use the graph paper that I've provided to do that. Go and I'll be also posting these examples. Okay.